Hello my friends, my name is Andrei Lee, or Andrei Lee PhD. I'm from Russia, St. Petersburg, so we are all taking part in PyTorch scholarship, and we had a nice conference call recently. And I promised you that I will upload to YouTube this nice video where I can explain what we discussed in conference call nicely. So here it is. So first, what we have to do? We have to do the following. So the whole idea is that we have 102 categories of flowers, and we want it to be categorized, classified in the different categories. So 102 categories, and we are just good to go to get it started. And we have nice image data set, so we have everything that we need. I will go in 3 steps. So first of all, I will show you brief general idea how it is done, and then I will show you more detailed solution. Then I will show you in even more detailed solution. So 3 steps. I want to have you general knowledge about this thing, and at the moment at Slack channel, PTorch Facebook scholarship, we are discussing different issues, and there are some problems. There are some problems that need to be asked. So asked it's by administrators of their our scholarship. So it's not clear what we have to do. So first of all, what is not clear? There is a rubric and there is our file image project, something like image classifier project. So in image classifier projects requirements are one, and in rubric requirements are different. So this is a very big problem. And what we have to do is to find the medium, or we are working at the moment at the Slack with group of people to clarify what is needed. But as far as we've got, we need only accuracy. So as long as Udacity server accepts your answer, you're free to go and you're cleared and you have nothing to do. So I had a fun today. I just tried to make it Udacity way, how it's all instructions are recommended, but I hope and I guess it's not required. So I'm showing you the simplest solution, the most simple solution. So for you to be clear about what you have to do. So first of all, we are kind of loading libraries, make a transformation that we can use, checking CUDA, define directories, loading images, get a number of images, load the data, load pre-trained model, reset guardian, getting the number of neurons in last layer of pre-trained model, initializing our pre-trained model, moving model to CUDA, load states that we saved. So you have to save before you load. So I just saved it before, that is why. So defining loss function, defining optimizer, training a model, save result of your model. This is my own accuracy calculator on that validation data. So the general idea is this. So what is more that I want to tell you about this in general part? So this code is working, so we can load libraries. I think I will have enough memory in my GPU to show you this, but I think it's not needed. You see, training on GPU, CUDA is available, directories definition, loading images, 652 images, train loader, model FT, define my model, and moving model to CUDA, and that's it. So what I want to show you. So we have a model. This is a raw model, ResNet 18. This is my model that I used. You're free to use whatever you want. So pushing the button. No, it's not correct. Pushing this button, A, and we are looking at the model. Model FT. This is our ResNet model. So this is a different in a parenthesis. These are different layers of the model. So we are leaving this part, this part untouched. So we freeze it. We don't update weights and everything else. So we change in last layer, this FC. So and we train to only this layer. So I want to mention that you have to use dropout. Although I submitted without dropout because I think it's logical. So if I will be cut in pieces, this is my problem. But metrics is accuracy. Nobody said that it's obligated, but in documentation it said there is obligation to use dropout. So I'm showing you what I wouldn't be doing if I had this freedom. So I had this freedom. That's why I will do this. Okay, in my own way. But you're free if you want to be secure. Absolutely, you have to include dropout. Okay, we reset gradients. So by this we are saying the model, please don't update these weights. Then we get a number of features. It's a number of features in our layer, in our model FT. So it's because it has to be sequential. So let me show you again that it is working perfectly well. Okay, this is where we are. Model FT and moving forward and model FT parameters and num features 512. So what does this mean? It means that before this FC layer, okay, we had here we have 512 neurons. So in our FC model, we should have here num features 512 in order to connect to other neural network that we freezed. So that's it. That's the general idea. If you have questions, I have a study group called Final Call. It's available separately for Russians and English speakers. So I'm not asking you asking your questions about the final project, but if you can get a group, I can answer your questions on whatever topic you want as far as I know. So if I don't know, I don't ask. I don't tell. Sorry. So this is our model, and let's move to deeper understanding of what's going on. So data transform. Here we do transformation. Center crop, precise to tensor, normalize. What's the center crop? It kind of get the center of the pictures, 500 by 500. So I made this little research and I understood that these images are for 500 by 500. Then we resize it to 224 by 224. It's for us not to train forever and not to run out of GPU memory or CPU memory or RAM. And here we are making a torch tensor. Then we normalize data to be from 0 to 1 using mean and standard deviation. So if you look at this data transform that we have here over here, it should be showing us the results. Okay, everything is perfect. Okay, so then we are checking if you have a GPU, and we have GPU is available. Trains directory. Here you should enter your directory. Image folder is a special class that handles labeling and getting your data from folders, your images. Then number of training images, number of test images. Here we load data using trail loader. We get this train data that we can find here. So everything is perfect, just perfect. Torch vision model, and we are setting gradient, number of features 512. So here we define the model using dropout. So this is my small innovation that I created somehow, but in reality, did I or not? So I looked at the autoencoder and they use similar technology. I called it Yolочка, so a spruce in English. This is a thing that Santa Claus is dancing around in the new year. Okay, so here I define model. So this is their modern, the most advanced definition of the model. You can use something like model equals sequential, and list your layers here like different nn dot linear or whatever. It's simpler, but it looks, my way looks more professional. So then we get last layer and replace it with our own layer, moving to CUDA. This is an important step, otherwise it will throw an error while you're training on this step. So it should be on CUDA. Although I'm moving to CUDA, it's here. So sometimes it's not working, so it's better to be safe. Load pre-trained state model, define loss, cross entropy loss. I use cross entropy loss, be careful. So this is not what we are discussing right now at the lab challenge project at Slack, whether to use cross entropy or NLL loss. So NLL loss is a safer way, but I like cross entropy for this case because I don't have to do conversion through the Torch XP. So here is my also little innovation. So I didn't use softmax. So be careful, because some even experienced people say, why you're not using softmax? Because you have to use softmax. It should be sum to 1. So, but in PyTorch official form, it was recommended to me to use linear, and I think it's more kind of state-of-the-art technology. But some people argue that you don't have to use linear, you have to use softmax, but the result is the same. So my model is accepted by the Udacity server, and I use my own tricks that somebody recommended me to make it work. Okay, model FT CUDA, and shall we see it more? The final loss, training the model. So this is how we train our model. It should be showing us something. Loss. No, doesn't serve gravity function. So I am probably running out of CUDA memory, I guess. Let's try it again, because I have another Jupyter notebook open with heavy GPU computations, so it might not work. Let's see, but it should be working fine. Let's wait. Okay, it will take a while, so it should be working. Don't worry, no mistakes. There should be epoch and training loss, and everything should be fine. This is the all my accuracy calculator. I didn't use recommended by Udacity way of solving this problem because I think it's very oh, it's working. So it's working. So so I'm not selling you wrong fruits. You're getting right thing. If you have something to say me like, hey, you need to improve here. Okay, let's improve. I'm not against improving. I'm open person, so you're free to recommend me whatever you think is important to this model. So this is like training accuracy 72%, 75%. So, but you can get maximum from my experience and from experience from lab challenge 92% if you don't use some kind of I don't know, you don't receive an explanation regarding this, but it should be fine. Okay, then yeah, saving the model after a lot of training. So I just push button here, gonna be mistake. It's not mistake, error. It's not error because I did something incorrectly, but it's error because we stopped. Okay, keyboard interrupted means that I stopped. So don't worry, you're good to go. And this is our own accuracy calculator on validation set. So this is how I done this. And this is over for medium part. So let's go in details. So here we load in libraries, data transformation that I explained to you already in pretty great detail, data loader, and I want to say one thing. So be careful. So don't implement your custom loader, because when I try to do this exercise, I decided no, I can do it on my own, and I can do my own custom data loader and other things. I know what to do, but the server labels are made by data loader, by particularly by image folder that creates labels. So this creates labels, and you should be careful with this, because labels are created not like kind of we have labels are from 0 to 101, but 0 is 1 and 1 is 10 and 3 is 100 and 4 is 101 and 5 is 102 if I'm correct, and 6 is 11. So this is a different logic, so don't do the custom loader, just do data loader and image folder classes. These are correct labeling. So I did this, and here I think there's no need to explanation. It's linear dropout, linear dropout. Here is ReLU. So we are kind of having this class. We made it, and X is going from here. So what I want to say you. So for example, what is more advanced way of doing this thing? So you can do like model ft forward and put some kind of image here, okay, that you already having, and do this. But this functionality is the same, but it's more kind of a professional, would I say? Should I say model ft image without forward? So this functionality is implemented in PyTorch, and it's using call method, like call this one. So this should be working fine. Okay, what else do you need? You need this kind of training the model. This is number epochs, and we're training this number of epochs. This is a train loss batch, and we going through the data in train loader. So we are getting batch ID, data and target from train loader because it's enumerate. We have a batch I, and train loader gives us data in target. So if you're training on GPU, it's correct. Output model FT, we get output. We calculating loss function. That is our cross entropy. Cross entropy, where's cross entropy? Over here. Okay, and train loss. Optimizer, 0 grad. We reset gradient in order to not mess with previous result. Loss backward, optimizer step. Then we do this and print. So model FT eval, model total correct. Arc max, I did my own way because Udacity way, it's kind of, I spent some time and decided that it's not uh, easy to understand. I would say this is easy to understand. Arc max, we're getting the maximum argument. For example, it's from 0 to 101. So it's, if it's correct, is 0. So we're getting the right label, and we are iterating over this and getting the total correct and other things. So the same is here. So this is in details. So why my voice is so slow as opposed to how I'm talking about usually? Because I try to do this in a way that was offered by Udacity. So when I was little tired, so first of all, this is a kind of a thing that we are provided, that we have to fill it in, and we're gonna be happy. So I did this my own way. So let's discuss how it should be done, but I guess it's not required. We are discussing this issue, so this should be done. Okay, imports. So here is clear, matplotlib inline, training on GPU, flower data, transform, image dataset, data loader, label mapping. So we have get to name JSON file, and here we fill in class to IDX, class to IDX, two categories names, building and training classifier. So this is my model, the same as I presented you before. Training almost the same. Saving the checkpoint. So you have to save some extra. Yeah, I saving only state dictionary. Here we load state dictionary. Image preprocessing, prediction. So and here's my own predict. This is the crazy thing. Like, I don't know how to call it, but it's pretty crazy. So it's it's a long thing, but I was debugging, and there was no other way to make it look like it's supposed to look, what Udacity is presenting. So what I want to say you, there is a peel preprocessing. So in my opinion, I don't see any logical reason if you have a data transform that is over here right at the beginning to do this peel way. I could have done this, but I started doing this and it looks pretty crazy. So what's the difference with my solution here and Udacity solution? Udacity solution, you provide a link to the image and it gives you a response. In my solution, you kind of getting random images. So it's drawing random images and showing you picture and reported probabilities for each picture. Okay, this is my solution, this is Udacity solution. So peel is extremely good, but I decided that I do random. So if you want deeper explanation, join me on my group, study group, final call. So, and thank you Facebook and Udacity for this great opportunity to learn more. But but instructions sometimes are not clear. So be careful, read the manual and understand it in a way that is needed to be and what is provided us by Udacity, but we will clear on Slack channel, lab challenge project, everything that we need. So thank you very much. Bye bye.